So I will write resistors and coil and capacitor. I can draw in that manner is the same. This is a coil inductor and this is capacitor. So this is um, kind of schematic that we have the same current through all that three components. This is serious. So we can write voltage resistor, voltage inductance, and voltage on capacitor. So we can add this and put 0. For example, just an example. For first is very easy. It's current multiply resistance plus this is inductance. Derivative of current which depends of time plus integrate current dt. This is from 0 or initial time to final time equals 0. But you can ask, why is that? Why you wrote in that way? First is very simple. Is Ohm law. Second one is Faraday. So the voltage on inductor is minus variation in magnetical flux, which depend of time. For capacitor, many times we wrote capacitor and capacity. That means how many charge can accumulate at a given voltage. Okay, so I remember that inductance equal increasing in magnetic flux that depend of time, and for this I can write voltage on capacitor is 1 over C and accumulated charge. So we know how we define intensity. That's mean charge that travel in a period of time. So we can take this, we put here, and obtain the equation and further in that way. So we can now first derivative that equation, that simple equation, and let's write. First, multiply resistance plus. Here we have first was in the first derivative. Now we have the second derivative plus. For capacitor is 1C I equal 0. Okay, 0. So we have now that equation, and we can solve that equation. But for simplicity, I will take the first part, or maybe the second is better, this, because many times we have something like this. Just 1 second. I said many times we have something like this in oscillator circuit, or something like equivalent in parallel oscillator circuit. Okay, so I will take just that part, and let's see how we can solve that. There is second derivative plus equals 0. But the current, there is a function of time, and we can write something like this. This is a typical Euler equation, and we can put I as e at power, let's say, xt. Okay, so we have this at second derivative plus over c okay. So we do the calculation in that way. Remember that current is a function of time. I will write just a second. To know how to derivate, I said this is a function of time is equal in fact we have some let's put here. Let's simplify with that. We have an amplitude of signal. So sorry for my English, and I will try to improve that. And now we have just plus equal 0. So we can move in that part. That's mean equal and minus 1 over so no, I cannot put T. I will put this letter multiply where I wrote this, the imaginary number square of minus 1. Okay, so we know that exponential of this, that mean something like this, and I think I will not continue, but it's very easy to understand. You can develop in Taylor series, and let's write. Okay, so have a component like this or like this. In easy word, we can write something like this. And is to pi. This is the angular speed, or frequency. So the frequency is 1 divided to pi square of x. Okay, I will stop here. I will stop here. I will not continue. I hope you guys give you the most important ideas to solve that. the fundamental ideas to know how to manage to solve that.